On your homework tonight, you'll see two sets of directions, and we've done these before, so it's just review. It says, without graphing, tell whether each equation is on the graph of, and then they'll give you some equation. Now this one's different than the one you'll see. This one says x minus 3y equals 12. So they'll give you a point, and you need to see if this point is actually on this line that's defined by this equation. And the same thing with this other point, see if it's on this line. So the way we're going to do that is we are going to take the equation here, and we're going to substitute this point in for this equation. So first of all, we've got an x value. The first number represents x, the second number represents y. So let me go ahead and just rewrite the equation. X minus 3y equals 12. So what we're going to do is we're going to take the x value, the 5, and substitute it in for that x. We're going to take the 1, which is y, and substitute it in for that y. Now when we do that, we've got ourselves 5 minus 3 times by 1, and then we see if that equals 12 or not. And so again, you're just putting the number in place of it. Now, when the 3 is right next to a variable, like it is here, that means we multiply 3 times that number. So we go ahead and do that work, and we end up with a 5 minus 3, and we see if that equals 12. In this case, those numbers equal 2. They don't equal 12. So that means no, that point is not on that line. Well, let's take a look at the next one here. Again, I'll just rewrite, well actually we could just go ahead and label what our x value is here. Remember, your x value is the first number, y is the second number. So we're just going to take this x value, put it in place of that x there. Take this y, put it in place of that y right there. And we'll see if it equals or not. So we go ahead and do that substitution. And so in place of x, I wrote 1 5/10 minus 3 times by negative 3 1/2. And then we'll see if it equals 12 or not. So we'll have some work to do here. We have to multiply the negative 3 by that negative 3.5. So I'll do that off to the side here. I'll write down 3 5/10, and it's negative, times by negative 3. And so when we multiply, the two negatives will cancel, but when we do this multiplication, we get 15, carry a 1, multiply these two numbers, this makes 9 plus 1 makes 10. Now we count the spaces after. There's only one space after, so the decimal point moves over one space. So this makes a positive because the two negatives cancel out. So now we've figured out what that number is. We can go ahead and rewrite our 1 5/10. Now it's going to be a plus 10 5/10. And this should all equal 12. If it does, we'll say yes, that point's on the line. If it doesn't, we'll say no. Well, whenever we're adding decimals, we want to line up the decimal points. So when I do this, I would have 10 5/10 plus 1 5/10. So you notice how I lined up those decimal points. And so when I add this, carry a 1, decimal point comes down, this makes 12. So I end up with 12 equals 12. So I would say yes, this point is on that line. Well, those are two of the types. Let's take a look at this other type here. The next direction, or set of directions, says use intercepts to graph a line given by the equation. So here's our equation, and we're going to use x and y intercepts. Those are the intercepts they're talking about. So the x-intercept, remember we set y equal to 0. So it cancels out this term. It's going to be gone, and all we're left with is that 3x equals 6. So we'll go ahead and write that part down. And then we've got one operation to do, and that final operation is just to divide by 3. And when we do that, it cancels out the 3 that's being multiplied by x, leaving us just with 2. So x equals 2. So when y is 0, x is 2. So we go ahead and plot that point on the x-axis 2 spaces over. Well, now we've got the y-intercept to deal with, and so we'll write down y-intercept, and for the y-intercept we're going to set x equal to 0. So when we do that, the x term cancels out. So all I'm left with is that negative y equals 6. So I'll write that part down. And now I've got to get rid of this minus sign out in front of the variable. And the way we deal with that is we multiply or divide by a negative, and that will cancel out the negatives, leaving me just with y equals. So y equals, in this case, negative 6. So the point is, when x is 0, y is negative 6. So what we'll do is we'll go over 0, but then down 6 spaces. Put a dot there. And now we've got 2 points in which we can draw a line between. So then draw that line between those 2 points. So we got the y-intercept and the x-intercept, 2 separate points. Well, one more problem to practice here. And we've got, again, to set up our 2 problems. We got the x-intercept. We're going to set y equal to 0. And so when we set y equal to 0, it cancels out the y term. So all I need to write down is what's left over. Just that x, or 1/2 x, equals 2. And then from there I can get rid of that fraction as the coefficient by multiplying by the reciprocal, 2 over 1. That'll cancel out the 2's there, leaving me just with x. So in this case, x equals 4. So we can write that as an ordered pair, 4, 0. So that means we're going to go up or down 0, but just over 4 spaces. And put a dot there. Well, let's take a look at the next one. We've got ourselves the y-intercept next. Remember, for the y-intercept, we want to set x equal to 0. So when we set x equal to 0, that fraction term cancels out. So all I'm left with is just 2y equals 2. Now I want to cancel out that 2, and the way I do that is just divide by 2. And then those 2's will be gone, leaving me just with the x term, or the y term in this case, the variable term. And so y equals 1. So when x is 0, y is 1. And so I'm just going to go over 0 and then up 1 space, put a dot. And then from there I can draw the line between those points. Then we'd have our graph. So those are the 2 types of problems you'll end up seeing. It's either telling whether a point's on a line and proving that by substituting, or graphing using x and y intercepts.